stuff? Okay. So that's all good for single sugars, monosaccharides. The last thing we need to talk about, and this will spill into Wednesday a little bit, is polymers. Is when we put them together. And the way we put them together is that hemiacetals, which hopefully you gained, hemiacetal is that carbon on the side right there that has both an ether linkage and a hydroxyl group. So our hemiacetals are still quite reactive because it is a single carbon that has two electronegative oxygens pulling charge density from it. Oops. So our hemiacetal is quite electrophilic. It is quite delta positive because there's electrons being pulled to this oxygen, there's electrons being pulled to this oxygen, that poor carbon is left in an electron deficient state. Which means if you have some sort of convenient nucleophile, like, I don't know, a hydroxyl group, it can attack and form a new ether bond. And when that happens, that carbon that has two ether bonds, here's one ether, here's a second ether, is called an acetal. Which explains why when there was only one, it was called a hemi, or half acetal. Because it had one ether, as opposed to the two. So we can form an acetal. And that bonding is typically called glycosidic bonding. Because biochemists are lazy. Glyco means sugar, and it occurs on the sides of the sugars. Sugar side bond. Bond between the sides of sugars. Glycosidic bond. Yeah. Notice, and you'll see, this can be attacked by any alcohol. Here it's drawn with this alcohol attacking, but it could have been that one, or that one, or that one, or even that one. There's lots of potential for how these bond together. It's actually much more complex than, say, amino acids, where there's one carbonyl and one amine. They form a peptide bond. Here you've got lots of different attachment sites. Other thing worth noting, I hate this. Look, it's a covalent bond that goes whoo. This is just to simplify it so it's easier to draw. In real angles, this guy's going to be like down here pointed at an angle, right? They're not going to be flat because carbon-oxygen single bonds don't bend that way. It's just a trick to make it easier to draw. Yeah?
Sorry, if you split this, where did the second OH go?
Well, there's the oxygen. Oh, over here?
Yeah.
We release water.
Oh.
Yeah. If we look here, and they tried to do it pink to kind of non-mechanistically show, we're going to lose a hydrogen and an OH as water. Yeah. So these are condensation reactions. When they come together, they release water. So we can put together sugars, and we need a way to talk about how we're putting them together, because they could go anywhere. They could be joined like this, but also this hemiacetal here could have joined up there, or it could have joined to that guy. Then I'd have to draw it like in 3D because they'd be kind of like perpendicular to each other or something. It'd be weird, right? But it could have. So here's the nomenclature. We say that it joined carbon 1 of this one to carbon 4 of that one. So we literally say 1 to 4 because we are lazy. Traditionally, but not always, the first one you list should be the hemiacetal containing one. Sometimes people get it wrong, but the hemiacetal that's reacting should be the first one listed. And we do note it was in its alpha configuration, right? So we have alpha D-glucose, 1 to 4 to D-glucose. Wait, why didn't I have an alpha or beta here? Because this is still sitting here, it can open and close and switch between alpha and beta. This guy is locked. Now that it's in this acetal, it can't reopen into a chain. But this one is still a hemiacetal, and we said hemiacetals are constantly opening and closing. So we kind of draw it as this little wiggly to say like, it could be either of them, or neither. It could be open up. It could, for some small, brief point in time, look something like Dr. Bond is going to draw, like that, right? It could be this guy linked to a straight chain. And then it'll close into beta, and then open, then close into alpha, then open, then close into beta. So when it's on the end, we can't really define whether it's alpha or beta, because it's just switching. Dig it? So glycosidic bonds, really easy. What are the numbers of the carbons that join? And that's what we do. And it gives us a lot of diversity. So for example, let's look at some. Here's some commonly occurring real ones. You do not need to memorize these. These are just examples to get your brain going. Lactose. Mammalian milk is full of lactose. Is a beta-galactose. Again, galactose is like sugar, but it's the C4 epimer. So at 4, glucose would normally be pointed down. Here it's pointed up. Beta-galactose, 1,4 linked to beta-glucose. Technically not a beta-glucose. You can just get rid of the beta if you want, because again, opens, closes all the time. But yeah, so lactose. Galactose joined to glucose. Sucrose, or table sugar, is fructose, beta-fructose, and alpha-glucose. Alpha-D-glucose linked to beta-D-fructose.
But not beta, so.
No, it is beta. This guy's drawn backwards. Its acetyl is consumed. We'll practice some more. We're almost out of time today, and I don't want to kill us. But the idea is that, before this reaction, that was its hemiacetal, because it had an ether and a hydroxyl, and now it's been consumed.
That's why it's listed first, because that's what it is.
Yeah, but this one's, well, it's kind of, you'll see they write it both ways, because this one also is a hemiacetal. It's two hemiacetals reacting together. So name it either way. Enjoy. And this guy is trehalose. By the way, don't you just love this too? You take two random things, put them together, and you get a whole new name that's unrelated. Yeah, it's the best way. I love memorizing random things. Trehalose is alpha-D-glucose with alpha-D-glucose. So again, lactose occurs in mammalian milk a lot. Sucrose is our table sugar. It occurs in several plant species in great amounts, and we harvest a whole bunch of them. Trehalose occurs in succulents. It actually is what helps retain moisture in a lot of succulents. So like aloe vera gel has tons of trehalose in it. Plus, it's kind of fun to say, trehalose. Sounds fun to me. This is just two sugars. What we're going to look at next time is what about when you start putting lots of them together? And they can get complex as anything. Here's your homework for next period. Find out your blood type. If you already know it, you're good. And if you don't know it, I doubt you can actually find out in 2 days. But think about your blood type. We're going to be showing what a blood type is. It turns out it's a type of carbohydrate. So, good times. Thank you for your time.